In this video, I will be talking about the result viewer table options of joining together multiple tables. Why would we want to join multiple tables? To create a more complex output of the SOFiSTiK software regarding a specific information that you want to showcase as a table. This is based on a so-called left source table that will be joined with a right target table. Here you can see, for example, the material and group assignment of the quadrilateral elements, and what we can do is we can join them together with the force results based on a load case as we see in the second table, but we could of course have multiple tables that we add together as well. SOFiSTiK now provides three options of joining together tables. The first option is the so-called left join. I will showcase this based on this simply supported beam, which is represented by structural line 101, which will then be meshed into finite elements, starting with the number 100,001 to 100,005. The left join option considers the first match of the source table of the left structural line, in this case table, with structural line number 101, matching the beam table that we see here, which starts at 100,001 to 100,005. The corresponding information matches together with the first intersection of the referenced number of the source left table to the target table. As you can see it here with left join, the first match will be considered, and the corresponding table that is represented here showcases that only one line will be output in this table, because structural line, the source table, searches for the first and only match of the target table. On the other hand, if we now use the right join, the second option, this one will try to match every single match of the source with the target table, meaning that not only one beam element will be matched, but all of them that consequently have the sub-SLN number of 101. As we can see it here, we now have 5 entries, and the source table will be repeated in the final table with the right join option. So all the matches will be considered. In very special cases, you might use the left outer join functionality. This one is a little bit special because what this functionality does is it matches the left, the source table, with the right target table, and sometimes some of the entries are unmatchable or no more values are available at the target table, and these values will then be represented with a minus. Here we can see once more this simply supported beam and the finite elements starting with 100,001 to 100,005. Every single one of these beams has a section at start and end, and every single section is assigned to a specific finite element node number. We can see here we start for beam element 100,001 with node number 4, and the end node number is 1000, with the second one starting at 1000 and going up to 1001. If we now take a look at the node deflections, we can see here the table which showcases all the corresponding nodes with their vertical deflection. If we now want to join this together with the already mentioned beam information that was also matched in the table before, and we use the left outer join functionality, we will get this table. And here we can very quickly see that node number 5 does exist in the left table, but does not match the node to node number 1 match that we did for creating this table, because it simply doesn't exist in the column node number 1 of the beam, meaning that it will be showcased, but it will give us a non-valid value in the table itself. In SOFiSTiK, make sure to calculate all the tasks so there is data in the database available to be referenced in our results as a table later on. Right-click into the project navigation, insert a new task, which is, of course, our interactive lists and graphics. Click on OK, and the task is added. I will rename this one to left join. And with a double click, I can start by creating a new table. The first information that I want to add is in system values. System values includes all the information about the structure itself, and we also have results and design here. But I want to have some cross-sectional system values represented, specifically general properties, and here I can select multiples by either holding Control or dragging over by holding the left mouse button. Click on OK, and the program creates my first line here, which includes section number 1, which is my first cross-section here. You could select multiples, of course, but I want to show the left join functionality where we specifically only want to showcase the first match that the program finds. With a double click onto the result, you can add additional table information. You can scroll down a little bit because additionally to the cross-section, you can also find beam element information, especially beam section properties. I open this one up, and while holding the Control button, I select cross-section number and click on OK. This is the table that the program automatically creates. You can see that it's not just one line because the program is smart enough to realize that this might not be the result that we want to have. But as an example, it is good enough because we can, of course, manually adjust everything. When you select the table, you can always come here and check the joined results tables. Click on the join functionality here, and you can see that table number B and table number A are connected via section numbers, and the left table is table number B. Let's quickly double check what table number B actually is. You can see here we have the final output and the source tables available, and the original table number A is our single line, and table number B is the beam cross-sectional properties with the assigned cross-section. If we were to turn around the alignment of these tables, so we switch table number A to be the left table, the input table, and table number B to be the target table. By the way, you can unjoin them by middle clicking onto this connection line. We switch them around and now make table number A the left table. You can immediately see that we only get the first match of the joined properties here. Just a quick overview once more. We have table number A with section number 1, and it will match the first match of table number B, which is our beam element 3001, which is represented here. Let's duplicate this task and rename it to right join. Right join, on the other hand, and by the way, I'm already in my new table over here, select the result and check for the join functionality. Right join can be activated with this little indicator up here that is represented by 2 overlapping circles. You can left click onto it and switch from left join to right join. You can immediately see that all the matches of section number 1 are assigned. Keep in mind that the source table of result B, which represents all the finite element beam elements, of course also has section number 2 available, but only matches with section number 1 will be represented in the output. You can see it here as well. Let's now create a more special use case where we will use the left outer join. To do so, I will once more create a new task, add the interactive lists and graphic, and this one will represent my punching nodes at quads elements. So I will call it punching quads. Double click onto it, create a new table, And in system values, now select first of all quadrilateral elements. In here, we want to showcase number of element group, secondary group, and node number 1. So this is the first of 4 defining nodes for our quad elements. And additionally to that, we now also want to showcase a couple of results based on the design of the quadrilateral elements, especially the nodes of the quadrilateral elements. So select nodes of quadrilateral elements, and what we want to match now is the punching force of these quad nodes. So hold the Control key, select punching force. Click on OK, and this is the table that is automatically generated by the program. But let's take a closer look at the source tables. Here we can see the quad numbers, as well as the node numbers of their first defining node. In result B, we see a design case, as well as a specific node number, which was checked for punching, and the punching force at this node. What the program automatically creates when we check the join functionality is a left join function of the first node with the nodes that actually were considered for punching. Let's check out what happens when we change this from left join. Remember, what the program in this case does is it checks node number 1 with the node definition in table number B and showcases only one match of this result. If we change it to left outer join, you can see that multiple nodes are here available for the corresponding quadrilateral elements, but they do not showcase any punching results because they were simply not designed for punching. And this indicator now allows you to see all the defining nodes and their corresponding punching forces. Let's now close this one and create once more a last interactive lists and graphics task, which in this case we will use to once more create a table. But in this case, I do not want to just simply join one table, I want to join multiples. So I want to start with system values, where I will select quadrilateral elements, where I want to have the element number, the group number, as well as the number of the material. Next up, in my results, I want to showcase quadrilateral element results, especially forces. In here, I will just select everything. Next up, I also want to select stress results. In this case on zeta, and I also just select everything which is within this folder. Click on OK, and the program now showcases the 3 tables, which we now can join together in a specific way. Let's check out what the source tables look like. The first table is result A, quadrilateral numbers, group numbers, materials. The second one, the blue result number B, has our quadrilateral numbers as well as the corresponding forces based on load case 11. We can join those two together already by selecting our table number A, and we know that the quad numbers fit together. Left join should be fine, but just in case, we can make a right join out of it. We can check our intermediate results over here, where we now can see quadrilateral elements, material, group, and our stresses. Next up, we have our result B that we can check in source tables, where you can also see that we can match it with quadrilateral elements, meaning that in every table, we just need one column to match together into our output here. We can either join it directly with A or make it continuous with B, where we can also tell it to right join over here. We can click on apply changes And this is now the table that showcases all the results that we want to showcase based on our quadrilateral elements. We can even change the order here to represent our results if we want them to be showcased like that.